All right, so today we're going to be doing actually quite a bit of algebra review. We're going to be talking about slope, specifically parallel and perpendicular slopes. And we're also going to be reviewing how to write equations of lines. All right, so we are covering quite a bit of material today, but the majority of it should be review. So let's start with slope, all right? Visually, here's our 4 different kinds of slopes. We've got a positive slope, because as you go left to right and this line is going up, this would be a positive slope. If your line is moving down as you move left to right, that would make a negative slope. All right. Horizontal line, that gives you a slope of 0. Okay. Our vertical line gives us a slope that is either called undefined, or you can say no slope. All right, but you would say m equals. Okay, so again, your horizontal is a slope of 0. That's an actual number. Our vertical lines are the ones that are undefined. Now, how will you know the difference? In a fraction, all right, 0 will be over top of a number, because 0 divided by any number is 0. So that's what will happen when you calculate slope. With an undefined slope, the 0 ends up on the bottom in the denominator, because you are not allowed to ever divide by 0. If you try it on your calculator, it will give you an error. Right? So what is slope? What does it mean? It's the steepness of a line. The steepness of a line. When you're doing word problems, it's the rate of change. All right, and that rate of change creates the steepness. Now in this box, you'll see your slope formula. All right, and it kind of looks a little tiny, but it is y1 minus y2 over x1 minus x2. Now, I'm going to put an or, because you might see the formula written with the 2's in the front, meaning you might see it written y2 minus y1 over, and if you start with the y2, then you have to just start with the x2. So these are the exact same formula, right? It doesn't matter if you start with the 1's or the 2's, but just be consistent. All right, when you're working with slope, right, and you have a coordinate plane, you can actually count the slope. And that's what I want us to do for this. All right, so we're going to plot point A is at -3, -2, and then B is at 1, 3. So when you're looking at a coordinate plane, all right, you don't have to use the ordered pairs. We can count rise over run. So what you do is you go up and make a right angle. So we're going to go up, and then we're going to go over, creating that right angle right there. All right, if I count from A to B, I'm rising 1, 2, 3, 4, 5 in a positive direction. And then I'm going to run 1, 2, 3, 4 again in a positive direction, because we went to the right. So that would give us a slope of 5 over 4. And then keep it in lowest terms, you'll be done. Now, if you wanted to count from B to A, you're allowed to do that. So if we make our right angle this way, just make sure that you realize that we're counting down. So 1, 2, 3, 4, 5 down, this makes a distance of -5. And then we count back to the left 4, so that would make that a -4. So you would have -5 over -4, which of course converts into +5/4. So we would get the same thing either way. Just pay attention to the direction. Up and right is positive, down and back or to the left are always negative. If you don't have a grid, like in the second example, then we're going to use the formula. So we're given 2 points. You identify which ones you want to be your x1 and y1 and which ones you want to be your x2, y2. It does not matter. Okay. And then pick one of the two formulas. I'll use the one that was originally given. Whoop. So I'm going to do the 1s minus the 2s. Y's on top. So I'm going to do 3 minus 6 over 5 minus a negative 1. All right. Well, 3 minus 6 is a negative 3. The double negative here becomes a positive. So we get positive 6 on the bottom. Always, always reduce. All right, so this is going to reduce to negative 1/2. All right. Parallel lines. Parallel lines concerning the slope have the same slope or slopes. All right, so if we're told that lines are parallel, then we know that their slopes are identical. Perpendicular lines have opposite and reciprocal slopes. Probably should have put a fourth line in there. Opposite and reciprocal. Opposite means one is positive, one is negative. Reciprocal, just to give you an example, if you had a slope of A, then the other one would be 1 over A. Okay, so you would flip it. So on the next page, let's look at some different slopes. All right, so here are our original slopes. So if we were given a slope of 5/4, then the parallel slope would be the same, 5/4. The perpendicular slope would be the opposite, so it's going to become negative, and then we flip it, 4 over 5. If the original slope is negative 7/8, then a parallel slope is exactly the same, negative 7/8, and the perpendicular is a positive 8 over 7. Original slope of 5, parallel is the same, 5. All right, perpendicular would be a negative, and then we would make it 1 over 5, because this is like a 5 over 1. 1/3, parallel stays the same, 1/3, and then the perpendicular slope would be a negative 3 over 1, but we don't write fractions and leave them over 1, so it's just negative 3. All right, our zero slope. Remember, this is a horizontal line. So parallel is going to be another zero slope. It's a horizontal line. Perpendicular would be a vertical line. And the slope of a vertical line is your undefined or no slope, whichever one you'd like to write. Okay, so remember that those are opposite and reciprocals of each other. Negative 8/5. Parallel is going to be the same. Perpendicular would turn it positive and make it 5 over 8. So what are we going to do with that? We're going to identify by looking at equations whether or not the lines are parallel, perpendicular, or oblique. All right, so I've got two equations. Let's review first. Y equals mx plus b. M is the slope. So you're always looking just for the number, if it's in y equals form, the number in front of the x. X is not part of the slope, just the value in front. So these are the two numbers that we are comparing here, 2/3 and negative 2/3. Well, they're obviously not parallel because they're not exactly the same, and they're not perpendicular. Even though one's positive and one's negative, they're not reciprocated of one another. So the only other option is that they are oblique. And if you remember what oblique means, is that they do intersect, just not at a 90-degree angle. Number 2, the two numbers we're looking at are the 4 and the negative 1/4. Again, obviously not parallel, but they are opposite and reciprocals. So these are perpendicular. We'll just use the upside down T for that. And then we've got 1/2 and 1/2, those are exactly the same. So those are parallel. Okay. All right. So moving on, determine if the two lines passing through the given points are parallel, perpendicular, or neither. Well, in order to do that, we need to know the slope. So if it's not given, we will find it. So we're going to find the slope for both line 1 and line 2. Again, identify if you need to, which are your x1, y1s and which are your x2, y2s. So if I always do 1 minus 2, the y's go on top. So 4 minus 0 over, and then I've got -2 minus a -3. So I'm going to have 4 over. This double negative becomes a positive. -2 plus 3 is 1. Please don't leave your answers over 1. That's just going to be 4. Over here, again, if you need to label, let's get these labeled. And then I'll do 1 minus the 2. So I've got 5 minus 1 over 4 minus 3, which is 4 over 1. So again, 4. They're exactly the same. These are parallel. All right. If I wanted to write them symbolically, then I would say line 1 is parallel to line 2, and I could use the cursive L like that. All right, let's do another one of those. So again, let's label our 1s and our 2s. The slope for line 1, we've got -2 minus a -5 over a -2 minus 2. Double negative is a positive, so -2 plus 5 is 3, and -2 minus 2 is a -4. All right, slope over here. We've got our 1s and our 2s. So I'll start with -1 minus 3, and then 5 minus 2. So -4 over 3. So to compare them, obviously they are reciprocals of each other, but notice that they are both negative. So they are not opposite each other. So these are, and the directions say to just say neither. All right, I'm going to add the word oblique because the question could be either one. They might actually say parallel, perpendicular, or oblique, or they'll say parallel, perpendicular, or neither. All right, now these are our notes, so I'm just going to write they are not opposite of each other. That's why they are not perpendicular. Okay. All right, the last thing we need to do is to review writing equations of lines. Okay. Now, there's 2 forms that you can use to write an equation of a line. The first one is what we call slope-intercept form. That's the y equals mx plus b. All right, because we've already talked, m is your slope, and b represents the y-intercept. All right, so those are the 2 things that we need to know in order to write that equation. The other form is this form called point slope form, and I don't know how many of you are familiar with that, if at all, but it is one that you need to be. All right, that form looks like this. You're going to take y minus y1, and that equals m, the slope, times, and in parentheses, you would do x minus x1. So this is called point slope form because we're going to put an ordered pair in for x1, y1, and then we're going to put the slope in for m. Point slope. All right. Both of these, though, help us write an equation. So as I do the examples, I'm going to do them with both. You get to choose which way you want to write your equations. All right, so here's the steps. First thing, we have to know the slope. In either one of those forms, we have to know m. So we have to determine that first if it's not known. If it's not known, then we've got a slope formula. We can use that to calculate it first. Now, we can use either form above, and what we're going to do is we're going to substitute the values of x and y. All right, x and y right here, this is going to be an ordered pair. All right, goes in for x and y in this one, and it'll go in for x1, y1 in the second one. And then, of course, m is the slope. So we substitute the ordered pair and the slope into the equation. If you're using slope-intercept form, after you substitute, you're going to have to solve for b. And then we write the equation by simply substituting back in the m and the b into y equals mx plus b. What I like about point slope form, and I will encourage you to use this, all right, is that we're going to substitute in, again, the ordered pair goes in for x1, y1 and the slope. And then all we have to do is distribute and put the equation into y equals form, and we're done. And your equation's right there. So there's no solving and then resubstituting. We only substitute once at the beginning. All right, so number one, we want to write the equation of a line that goes through these 2 points. Okay, so we need to know the slope. We weren't given the slope. So that is step one. So over here, let's do that. All right, so we've got x1, y1, and x2, y2. So again, 1's minus the 2, so I'm going to have -5 minus 3 over 0 minus 4 gives me -8 over -4, which will be +2. So my slope is 2. Now I get a choice. I can pick either one of these ordered pairs. Now for this one, I'm going to kind of do a little cheat, because something I notice, and I want you to notice, is that 0, -5, this right here is a y-intercept. All right, think about it. 0, -5 is going to lie right on the y-axis. That's what a y-intercept is. So I already know B. B is -5. So when you recognize that, okay, and again, it has to be 0 as the x in order to be a y-intercept, then we're ready to write our equation. It's going to be y equals 2x minus 5. Now, that doesn't always happen. All right, I picked that problem specifically so that we would recognize that we already had a y-intercept. So all we needed to do was find the slope, and we could put them together. This next one, notice the points, no y-intercept. All right, but step one is still find the slope. So let's do that. So we've got x1, y1, x2, y2. So I'll have 3 minus a -5, y's on top, and then 3 minus 1. So the double negative is a positive, so we'll have 8 over 2, which is 4. So my slope is 4. Now, if I'm going to use y equals mx plus b, told you I was going to do this both ways. All right, then let's pick, and I'm going to pick this ordered pair. You can use either one, but I'm going to pick the one with the 3 and the 3. So I put the y coordinate in for y. I put the 4, because that's my slope, in for m. And then I put the x coordinate in for x. And so what I need to do is solve for b. So I've got 3 equals 12 plus b. And when I subtract 12, we get -9. So I would put my slope and my y-intercept together and would get y equals 4x minus 9. All right, now let's do the other way. Let's use the y minus y1 equals m times x minus x1. Now, you don't need to write that formula every time. You can write it with the number substituted in if you're going to use this method. Again, I encourage you to do this. It's just giving you a head start into Algebra 2, makes everything a little easier. All right, so again, if I use the same point, I would do y minus the y coordinate equals m, which was 4, times, and then x minus the x coordinate. And then I distribute. So I've got y minus 3 equals 4x minus 12. And then all I have to do to get it into y equals is add the 3. And I've got y equals 4x minus 9. All right. You pick which way you want to do it. Now, let's add this parallel and perpendicular into this situation. So we want to write the equation of a line that passes through this point, 2, 4, and it's parallel to the line, or a line. How about that? A line with the equation y equals 3x plus 2. All right, so what's step 1? We need the slope. They didn't give me 2 points, so I can't calculate it. So I'm going to get it from here. If it's parallel to this equation, then it's going to have the same slope. So if m here is 3, then the m I want is 3. All right, so I've got my slope and I've got a point. All right, let's do y equals mx plus b first. All right, here's my x and my y. So we're going to put 4 in for y, 3 in for m, 2 in for x, and we're going to solve for b. So I've got 4 equals 6 plus b, and when I subtract the 6 over, we're going to have negative 2 equals b. So my equation is y equals 3x minus 2. If you do the point slope form, again, these are our notes, so I'm just writing the formula down. You're going to show me y minus the y coordinate of 4 equals the slope, which is 3, times x minus the x coordinate of 2. And then all I need to do is distribute. So I get 3x minus 6 on the right, and then add 4. Final answer, y equals 3x minus 2. And our last problem. We want to write the equation of a line that goes through this point, 3, 2, but is perpendicular to this one. All right, now I want to change this problem because I want us to have a negative. So let's just make this 3, negative 2. All right, I'm going to change that up. So we want this time to be perpendicular. Perpendicular lines don't have the same slope. They have opposite reciprocal slopes. Now notice this equation is not in y equals form. So let's do that. Let's get y all by itself we're going to add 3x over, and we get y equals 3x plus 6. That way I can actually identify and see that the slope of this equation is 3, but I want a perpendicular slope. I want a perpendicular m, so I'm not going to use 3. I have to use a negative 1 over 3. So this is the slope that we want to use. All right, the 3, negative 2 are going to be the x and the y that go into one of our 2 equations. Let's start with the first one, y equals mx plus b. So I would put the y coordinate, which is now negative 2. I would use the perpendicular slope, which is negative 1/3, times the x, which is 3, plus b. All right, so think of this as 3 over 1. So when you multiply, negative 1 times 3 is negative 3. Divided by 3 is going to be negative 1. Or use your calculator. And then when I add 1, we're going to get -1 equals b. So y equals, again, we're using our perpendicular slope always, is -1/3 x minus 1. All right, if we use the point slope form, which is y minus y1 equals m times x minus x1, I would put the -2 over here. Now this is what I wanted, because this is y minus a -2. All right, the slope we need to use is -1/3, and then this is x minus a +3. So over here, this double negative becomes a positive. So this is really y plus 2 on the left. And then when I distribute, I get -1/3 x plus 1. -1/3 times -3 will be a +1. And then if I subtract the 2, final answer, y equals -1/3 x minus 1. Okay? Again, you get to choose. Are you going to use y equals mx plus b? Or are you going to challenge yourself a little bit if this is a new formula, all right, and try using and practicing that when you are writing equations. It will help you as you get to the next course for sure. All right, we covered a lot today, a lot about slope and writing equations. So do your best, come for help if you need it, but you should be ready to do some practice.